Listen closely. You are not hearing music. You're hearing a star trying not to die. Not screaming, not exploding, just folding. Somewhere out there, perhaps right now, a giant is falling inward. A star 10 times the size of our sun is running out of fuel. And with no more light to push outward, gravity wins. In less than a second, its core shrinks to the size of a city. All the atoms, the iron, the hydrogen, the heat, crushed so violently that the very structure of matter breaks. Inside, the protons and electrons scream together and become something new, neutrons. And just like that, the star is gone. What's left behind is something that should not exist, a neutron star, 20 kilometers wide, mass greater than the sun, spinning hundreds of times per second, and so dense that a single teaspoon would weigh more than Mount Everest. And here's the most terrifying part. That collapse might have happened 1,000 years ago, or 1,000,000. But the light, the warning, is only just arriving. Because every time you look at the night sky, you're looking into the past. That warm little sparkle you see, it might already be gone. Space hides its horrors well. What we call now in astronomy is a lie. That neutron star could have formed before humanity ever lit fire, and yet tonight, its light finally reaches us. If it happened close enough, you wouldn't feel it. You just vanish. Like an error in the code, no sound, no warning, no time to think. And then, something even stranger happens. That dead star begins to spin faster and faster until it becomes a cosmic lighthouse, blinking signals across the galaxy, beams of energy so precise they can rival atomic clocks. And if one of those beams hits Earth, we see a pulse again and again and again. In 1967, humans discovered the first one. It was so regular, so artificial. They thought it was a message from aliens, but it wasn't. It was the heartbeat of a corpse, the final rhythm of a star that had already died. That's what a neutron star really is. Not just a remnant, but a message, a monument to forces we still barely understand, a warning from the edge of physics. And the most haunting truth, there are millions of them, spinning in silence, waiting for us to look their way. Their light may be old, but their story is far from over. Even the past can still kill you. It should have ended there. The collapse, the neutron star, the silent core spinning in the dark. But for some stars, death is only the beginning of something worse, because not all neutron stars are the same. Some are born wrong. They break the rules. They mutate. They evolve into something the universe itself seems unprepared to explain. And that's where our nightmare truly begins. They look like neutron stars, same size, same weight, same impossible density. But inside, something different, something twisted. They are the Magnetars, the cosmic deviants of the stellar graveyard. Their very existence shouldn't be possible. Their magnetic fields, 1,000 trillion times stronger than Earth's. Let that number sink in. 1,000 trillion. That's not just powerful, that's incomprehensible. These stars are so charged, so unstable, that they literally tear themselves apart from the inside. The crust, a solid shell of degenerate matter, cracks under the stress of its own magnetism. And when it does, it doesn't explode, it doesn't burn, it screams, a burst of energy, gamma rays, searing invisible light, rips through the cosmos at the speed of light. And if you're in the path, there is no escape. In 2004, Earth got lucky. A magnetar, 50,000 light years away, suffered a small twitch. its crust shifted by just a few centimeters. That's all. But the burst it sent out? It hit our satellites. It knocked out sensors. It temporarily ionized part of our upper atmosphere. And it was just a hiccup. Imagine what a true quake would do. Now imagine that same magnetar just 10 light years away. There's no warning, no countdown, just light, blinding, burning, and then silence. Everything biological, electronic, digital, erased in an instant. Gone, not by war, not by impact, by a ghost in the sky. But magnetars are only the beginning. Because when some neutron stars collapse even further, when they're too massive, too chaotic, they don't just spin or quake. They mutate into something even more alien. Some theorists call them quark stars. We think we understand matter, atoms, protons, neutrons. But crush it hard enough, dense enough, and even neutrons disintegrate. What's left is a soup. A fluid sea of quarks, the fundamental building blocks of reality. A star made of pure broken essence. It doesn't glow. It doesn't pulse. It just is. A frozen wave of collapsed matter. A being made of the last possible state before oblivion. We've never seen one for sure. But the math says they're out there. And if they are, they might not be alone. Because quark stars might not be the final form either. There's a darker theory, one whispered in academic circles and late-night physics forums. Strange stars, stars infected with a hypothetical material known as strange matter, a bizarre form of quark matter that may be contagious. Touch it, and your atoms convert, not burn, not melt, just change. A neutron star colliding with a normal star infected by strange matter could transform the entire mass into itself. Now imagine that touching a planet, touching Earth, one contact, and all matter begins to rewrite itself in a runaway cascade that turns the crust, the core, the air itself into a new substance. Cold, lifeless, stable, and utterly alien. But there's one more contender for the strangest of them all, a thing that may not even be a star. It doesn't pulse, it doesn't flare, it doesn't radiate. It sits, silent and lightless, where a neutron star should be. And yet, it behaves differently. Some call it a gravastar, short for gravitational vacuum star. It's not a neutron star, it's not a black hole. It's something in between, a hollow shell of exotic matter surrounding a core of dark energy, a trick, a cosmic imposter. From the outside, it bends light like a black hole. It distorts time. It warps gravity. But there is no event horizon, no singularity, no crushing doom at the center. It's like a mask, fooling even the laws of physics into thinking it's something else. We can't see it, can't confirm it. But the models say it might be real. And if so, then what else is? What else lies in the stellar graveyard, hidden among neutron stars, pulsing like normal, but not normal at all? What secrets are still sleeping in the silence between gamma bursts? Because maybe the real terror isn't the collapse. Maybe it's what comes after, the evolution of death itself. They were once the universe's quiet dead, left behind after supernovae. Forgotten, cold, final. But over time, something shifted. We realized neutron stars weren't just aftermaths of violence. They were keys, instruments, experiments written in the language of the cosmos. Somewhere out there, two of them are dancing, orbiting each other with maddening speed, hundreds of times per second. Locked in a gravitational embrace so tight, they churn space-time like a spoon in thick syrup. Every orbit, every millisecond, creates tension, friction, a buildup of energy in the very fabric of reality, until one day, they collide, and when they do not explode. They echo, Gravitational waves, that's what they send us. Not light, not heat, movement. Ripples in the structure of space-time itself, predicted by Einstein over a century ago, but laughed off for decades because who could possibly detect something so small, a ripple stretching space by a fraction of the width of a proton? Impossible. Until it wasn't. In 2017, it happened. A gravitational wave rang through the Earth, a soft tremor in the void. And for the first time in history, we heard the death spiral of two neutron stars. 130 million light-years away, they collided, and Earth quivered. The detectors at LIGO and Virgo, kilometers-long tunnels of silence and precision, recorded the moment with impossible accuracy. It was the first time we saw a cosmic event, not through light, but through pure gravity. The collision didn't just warp reality, it created reality. Heavy elements, the very building blocks of our civilization, were forged in that moment. Gold, platinum, uranium, atoms we mine and use, atoms in our jewelry, in our nuclear reactors, in the electronics powering this very screen. All birthed in the death throes of neutron stars. Stars may build the basics, hydrogen, helium, carbon. But neutron stars, they are the foundries of the rare, the dense, the extraordinary. But the story doesn't end with collisions, because even when they're alone, even when they're simply spinning in darkness, neutron stars can still speak. Some of them pulse. Beams of radio waves shoot from their poles like cosmic lighthouses. We call them pulsars. And their timing is perfect. So perfect, in fact, that no human clock has ever matched their precision. Some pulsars spin hundreds of times per second, blinking out bursts of energy with atomic regularity. And that timing, it's not just a curiosity, it's a tool. Astronomers now use pulsars as a kind of interstellar GPS. By tracking the pulses from different neutron stars across the sky, we can triangulate positions in deep space, navigating the galaxy not by constellations, but by cosmic heartbeats. These stars are dead, but somehow they're guiding us. They also let us test the universe itself. By measuring the tiniest changes in a pulsar signal, microseconds shaved off by gravitational distortions or time dilation, we've proven some of Einstein's most bizarre ideas. Time really does bend near mass. Gravity really does slow down clocks. Space-time isn't just a background, it's an active participant. And neutron stars are how we know. Some pulsars even come with companions, white dwarfs or other neutron stars, and watching how they tug at each other over decades gives us a window into forces we could never replicate on Earth. We've hunted dark matter this way. We've tested theories of gravity beyond general relativity. We've looked for extra dimensions. Every pulse, every tick, it's all data. And it's coming from the most extreme laboratories in existence, forged not by human hands, but by collapse, by pressure, by death. And here's the twist. We didn't build them, we didn't program them. Yet they're out there, in every direction, ticking away with a kind of mechanical elegance that puts human technology to shame. It's almost as if the universe itself wants to be measured, wants to be understood. And so it left behind these cosmic metronomes scattered through the void, waiting for us to notice. And when we did, physics changed, because we're not just using neutron stars to study them, we're using them to study everything else. The curvature of space-time, the origins of matter, the structure of galaxies, the very question of why reality behaves the way it does. Neutron stars were born from destruction, but they've become our greatest teachers. Even now, projects like the Pulsar Timing Array are turning these dead stars into an invisible telescope, one that maps gravitational waves not from one event, but from everything. A chorus of tiny signals, over years, over decades, all adding up to a hidden song in the fabric of reality. And it's working. In 2023, astronomers detected what may be the faint background hum of supermassive black holes merging across the cosmos. Not by light, not by X-rays, but by how they subtly warp the rhythm of distant neutron stars. These aren't tombstones, they're instruments. Record keepers of the cosmos. They don't blink randomly, they speak. In mathematics, in gravity, in truth. We can't get close to them, we can't bring one home, but their signals cross the galaxy, and through them the dead are teaching the living, not just about where we are, but where we're going. They are the strangest objects we know for certain exist. Not black holes, not dark matter, not string theory or the multiverse. Neutron stars. Because unlike so many cosmic mysteries, neutron stars are not hypothetical. We've seen them, measured them, watched them spin, pulse, collide, and tear holes in the fabric of space-time itself. And yet, we still don't understand them. Because neutron stars don't just challenge physics, they break it. They compress matter until it stops behaving like matter. They twist space and time into knots. They warp gravity into something primal, something that feels almost deliberate. And now a new idea is emerging, quietly, carefully, whispered in the back halls of physics departments and deep space observatories. What if neutron stars are pointing to what comes next? What if, locked inside their impossible cores, is the next chapter of reality? Because inside a neutron star, something breaks. Not the star, the rules. Our two greatest theories, quantum mechanics and general relativity, start to argue. They don't just disagree, they completely fall apart. One speaks in probabilities, the other in certainties. And trapped in between is the neutron star, a pressure-sealed paradox, a cosmic battleground where the laws of nature begin to contradict themselves. Some physicists now believe that deep inside the most extreme neutron stars, beyond what we've ever imagined, matter transforms. Not into atoms, not even into neutrons, but into something more raw, quark matter. A dense, featureless soup of up and down quarks, the most fundamental particles we know. But maybe there's something even deeper. Strange quarks, charm quarks, or something else, a type of exotic matter that hasn't existed since the first microseconds after the Big Bang. And if we could study it, hold it, replicate it, we wouldn't just learn something new, we would rewrite physics. Because in that moment, a neutron star stops being a tombstone. It becomes a vault, a sealed chamber, forged in the heart of stellar collapse, still holding the blueprint of the early universe. Not a corpse, a probe, an experiment, still running, still ticking, still broadcasting clues in beams of radiation and waves of gravity. And maybe, just maybe, it's whispering instructions for what comes next. A new understanding of time, a new relationship with energy, a new version of the cosmos itself. Because here's the quiet truth, the one few dare to say out loud, everything we know, from gravity and temperature to the creation of gold and the flow of time, is shaped by what stars do when they die. And when one refuses to die completely, when it collapses and somehow survives, when it becomes something stranger than a black hole, we have to listen. Because these are not just relics of the past, they are bridges between what we understand and what we don't, between the rules we know and the ones we've yet to write, between this universe and whatever comes next, between our oldest questions and the future of physics. This is Uncharted Odyssey, and if you've made it this far, through collapsing stars, cosmic lighthouses, and ripples in space-time. Thank you. Thank you for venturing into the unknown with us, because neutron stars aren't science fiction. They're real. They're out there, and they are rewriting everything we thought we understood about the universe. If tonight's journey made you think, if it sparked your curiosity, if it gave you a glimpse into something bigger than yourself, then consider subscribing, because here at Uncharted Odyssey, we don't just tell stories, we go deeper into the cosmos, into forgotten science, into the mysteries reality doesn't want to explain. And there's so much more ahead. Black holes that erase information, planets that shouldn't exist, particles that rewrite time. This is just the beginning. So hit subscribe, turn on notifications, and join us every step of the way as we dive into the unknown. One impossible question at a time. Until next time, don't look away. The universe is still watching, and it's not finished yet.